All right, so this is really two lessons, 16.1 and 16.2. We're going to be using the equations that we've already talked about to solve specific problems, one type of word problem and then one type of algebra equation. So you all know we're used to equations set up in this format, y equals, and I'm just picking some random numbers here, 7 1/4 to the x. Today, or when we were graphing, we talked about how this right here is the y-intercept, or our starting value, and we know where it's starting based on the exponent up there. And then we said that the value in the parentheses that has the exponent on it is going to be our ratio, our common ratio, which is going to tell us what we're multiplying or dividing by. So, for instance, this is an example of either multiplying by 1/4 or dividing by 4. Those both mean the same thing. And if you don't believe me, you can take your calculator and pick a number and multiply it by 1/4 or divide by 4, and you will get the exact same thing. So the first thing I want to talk about is how to solve some of these algebra equations. And our first problem is going to look like this, which looks similar to the format that you're used to. The only difference here is that notice we don't have a y equals, and instead of y equals, they're giving me this 96. So I still know the same things. I still know that the y-intercept or the zeroth term, however you want to say that, is 3. So I know that the zero term is 3. And I know that the common ratio here is going to be 2. So obviously to go forward, I'm going to be multiplying by 2. And instead of y equals, again, this says 96. This is where the y equals part would be. So if you think about when we make our tables of values, we always start and we put the y-intercept in the middle, 0 and 3. And this is asking where in this y part of the table, because the top of the table is always x and the bottom is y, where am I going to hit that value of 96? So really, I just need to work this out. To go forward, I'm going to multiply by 2, so that's going to give me 6, 12, 24, 48, 96. All right, so I've hit 96. That's going to be my target number. That's what that y equals here means. And the question is when, right? That's what x stands for. What term did I hit 96? So this is 1, 2, 3, 4, 5. So the answer is, and you can write it in two ways. You can either write x equals 5, or we can write the fifth term is 96. All right, those both mean the same thing. So that's our algebra problem. So here's our second type of example for today, and that's going to be a word problem. These word problems actually tend to be a little bit easier than some of the other word problems we've done this year, so don't freak out about how this is going to be set up. And just to make sure that you have good notes written, I would like for you to make sure that you have this problem, the actual words copied down to use for this example. Okay, so what we have to do now is take the information that they've given us and write an equation like the one that we just solved. So just like we wrote before, if we're going to write an equation, we need to know, if nothing else, we need to know the starting value and the pattern, or what they're calling now the growth rate. All right, so my starting value, if you read this, currently it says it has 2,000 elk. So my starting value is 2,000. It's increasing at a rate of 8% per year. So this is very important for you to know. Anytime you have percentages, you have to write them as decimals. So remember, 8%, when I go to write that as a decimal, I have to move the decimal place 2 times. So that's the same as saying 0.08. And now, if you take a second to think about 0.08 as it stands, that right there, if I tried to use that in my equation, that number is less than 1, right? That's a fraction, which means my values would actually be getting smaller. But it says it's supposed to be increasing. So to fix that, what we do, and we'll spend a little bit more time doing this tomorrow and throughout the week, but to fix that, instead of just putting 0.08, we call this 1.08. That's going to mean we get to multiply to make the value bigger instead of divide. So before I even talk about answering the question, I want to write my equation. So I'm going to have y equals, all right, we got 2 spots, remember, my starting value, which is 20,000, and then my pattern, which now my pattern is a percentage, 1.08. And if I were taking notes, you may want to just make a note to yourself that this is the pattern, but it is also the percentage. Now, in this specific example, they actually tell me what the population is that I'm curious about. They say the population is 40,000. You could have known that even if they hadn't given you that number. It's saying doubled, so that's how you know what value they're talking about. So the ending population is 40,000, which means they want me to solve this question. 40,000 equals 20,000 times 1.08 to the x. Okay, now to solve that, we're still going to go with the table. At some point I may show you another method just to maybe make some of the numbers easier, but for right now we're going to start with our table. And our starting value is 20,000. Why did I do that? 20,000. And remember, our pattern going forward, we want it to get bigger, so we're going to multiply by 1.08. And we would go backwards, we would have to divide by 1.08. Remember, we don't want it to get smaller, and actually going backwards would take us into negative years, so we need to go forwards with 1.08. So since that's kind of an odd number, I'm going to pause and let you use the calculator on your phone, or I'll use the calculator for us, and we can get our table of values so that we can continue answering this question. Okay, so all I did was I took my calculator and I just continued to multiply by 1.08 every single time. And when I did that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like somewhere between 9 and 10 years is when the population doubles, but it's really, really close to 9 because I'm looking for 40,000. So my final answer to this question would be that the population doubles somewhere very shortly after 9 years. And because these numbers kind of get so crazy, and it could be that we have to do the pattern a lot of times over and over again, what I'm going to do tomorrow is show you how to use your graphing calculator to make this table. So if you will, put a big star in your notes next to this example and that says graphing calculator, so that you remember we should be doing this in a graphing calculator probably instead of just multiplying over and over and over again. And we'll show you how to do that tomorrow. Before you watch this next little section, I just want to give you a heads up that there's a typo on this page. When I talk about range in this slide, I have written that range y is greater than or equal to, but you all know that because there's an asymptote, it can't be equal to, so the only thing I can write is that y will be greater than whatever value is given. All right, so we're still talking about exponential functions. Today we're going to talk specifically about growth and decay. So growth and decay, these are just some fancy words for the graphs that you've already seen before. So growth is something that's going to be getting bigger, right? And it tends to look, kind of get steep really, really quickly. So remember, we talked about these get large very quickly and they get small very quickly. So there's my growth. And then decay, very similarly, just gets small very quickly. So the two things that I want us to note here, though, that are new, domain is going to still be all real numbers. Remember, for the most part, our domains are always all real numbers. And that's because these are going to continue in the x direction forever. Think about our table, right? Like we could multiply or divide. We could go either direction. Even though some directions give us difficult numbers to deal with, we can still keep multiplying or dividing. Our range, however, is what's going to change. And our range, notice that, and you'll see this when we really start working these problems, these functions never really dip below that x-axis, which means my y values are always positive. So then my range is y greater than or equal to 0, because this graph is never dipping down here into the negative y values. It's always going to stay positive. All right, the same thing for decay, y going to be greater than or equal to 0. All right, and then a last few things I want you to know about growth versus decay. growth has these three components. It's going to be getting bigger, which we already talked about that last week. The pattern is going to be greater than 1, which we kind of touched on just a little bit yesterday. And it's going to be in this same format where the first number is still going to be my starting value. And then when we talk about the pattern itself, we are going to do 1 plus the percent that they give us. And remember, the percent that they give us, we want to write the percent as a decimal. In comparison, decay functions are going to get smaller. They have a pattern that is less than 1. And the function is still going to look very similar, where this first value is the start, and the parentheses are the pattern. However, this time we're going to do 1 minus the percentage, just so that we get a number that's less than 1. That's the only way we're going to be getting our function to be smaller in the end. So we're going to do 2 examples today. This is one of them. And the first thing we're going to do is we need to write an equation using the information they give us. So it says a painting is sold for $1,800, and that is going to be my starting value. And then it says the value increases. So that should make a key note to you that this is going to be an example of growth by 11% each year. So using that information, I can go ahead and write my equation, and that's going to be f of x equals my starting value. Because it's growth, we're going to do 1 plus the percentage to the x. Okay, so my starting value is 1,800. 1 plus the percent. Now remember, 11%, we have to change that to a decimal. So the decimal place is at the end. We move it twice, that's going to be 0.11. Now this question is specifically asking us to find the value of the painting in 30 years. So what we're going to do is we're going to use this equation. We're going to use the table function in our calculator to answer that question. So because our calculators are at school, this is one that we'll come back to tomorrow. So in your notes, you just need to leave some space so that we can work this problem and get a final answer tomorrow. Okay, so here's another example. This one tells us that the value of a car is depreciating. Okay, depreciating is another word for decay at a rate of 5% per year. So this is going to be the percentage that I use with my pattern. Remember, 5%, I'm going to need to fix that. So I tend to go ahead and write that as 0.05, move the decimal 2 times. And then they already give me a starting value of 32,000. So when I go to write my equation, I have f of x equals the starting value, 32,000. And then because it's decay, I want to do 1 minus this time, 0.05. And then we have to have our variable as our exponent. And just like our last example, we are going to use this function in our graphing calculator to answer the question, what will the value be in 2013? So again, you probably need to go ahead and copy the question down. And tomorrow we'll start with our graphing calculators on how to use the table function to answer this question in the easiest way possible.